diuretics, I just told you the whole mechanism, how there is a handling, how the nephron handles the sodium and various other cations or anions associated with this concept. Now, I would come to this topic. You must be fatigued till now that I haven't discussed any diuretic. So here I discuss. Actually, we have a drug. This is the normal physiological function I just told you. Actually, we have a drug that comes and binds with this. It is very ferocious. See, this is very ferocious. You can have a look at this. And what is it doing? Yes, what is it doing? It is binding with the carbonic anhydrase. See the beauty of this drug. It is binding with carbonic anhydrase. So what would happen? What would happen? See, it's very, very simple. If carbonic anhydrase, I mentioned that time only that carbonic anhydrase is a very, very important enzyme for the binding of these two ions and formation of carbonic acid. See, if there is a drug which comes and binds at this point, then do you think carbonic acid formation would be there?
No, sir.
No. Do you think if there is no formation of carbonic acid, how could carbon dioxide be formed?
No form.
There is no chance of carbon dioxide formation. Do you think if there is no carbon dioxide is present here, how could it be transported? How could this H positive be generated? It won't be generated. And see, if the concentration of H positive decreases in this proximal terminated tubular cell, then this transporter which is pumping the H positive from the cell to the lumen would become slow, because it is, I told you that time only, that because this is an agent which actually has to take care of two ions, sodium as well as H positive ion. So if H positive concentration is decreased, then enough H positive is not available to be transported at this lumen, and this pump becomes slower. Sodium, do you think now sodium reabsorption would be proper? There would be no sodium reabsorption because this pump has been inhibited, has been slowed down. So much of the sodium would leak out from this part and it would be subsequently passed into urine. And I told you in the beginning of the lecture that this is the girlfriend basically. And when the girlfriend is taken care of, the boyfriend, where is the boyfriend? See, the boyfriend. This is the boyfriend. Oh, it's missing. Boyfriend is missing his girlfriend, and it would love to follow this, and this drug would be acting as a diuretic. Is it clear to everyone? And what is the name of this drug? Yes, anyone? Anyone who knows the name of this drug? Yes, you. What is the name of this drug? Yes, you know the name of this drug? You don't know? Let me tell you. This is a very important diuretic, acetazolamide. This is the mechanism of action of acetazolamide. This is how acetazolamide takes care of the sodium by inhibiting the carbonic anhydrase. This point is worth mentioning here, that it inhibits the carbonic anhydrase, and this is how this whole cycle gets disrupted, and the sodium would be lost in the urine. Along with the sodium, water would love to follow along with the sodium, and water would be released, and this drug would be, of course, I told you natriuretic agents are diuretics as well. So if it is a natriuretic, then of course it is a diuretic. This is how the mechanism of action acetazolamide works. This is one class of drug. See, I would tell you the exact classification of the diuretics in the later part of the lectures, but right now I have discussed one class of drugs, that is the acetazolamide and its congeners. Okay. So anyone having any doubts regarding this topic can ask.
Yes, sir. Sir, is this acetazolamide is going to inhibit the carbonic anhydrase enzyme which is present inside of the PCT cell?
Oh, very intelligent question by this boy, young guy. Okay, let me tell you. Actually, there was I was trying to skip that point, but he's a very sharp student. He has already answered 2 questions of mine, and now he is going to trap me. Yes, let me tell you. Actually, in the beginning of the lecture, I told you that these carbonic anhydrase are different. That's why he might be thinking that if it is going to inhibit this, then what is the fate of this carbonic anhydrase? But actually, these both are structurally same. These both are structurally same. I mentioned that they are physiologically different, they are different, but actually the structure is almost the same. And as far as a drug is concerned, the drug is blind. Do you think drugs have eyes to see where it is going to act? No, drugs don't have eyes. Drugs, oh, sorry, I have made eyes, that's why you are confused. So let me, erase these eyes. Drugs don't have eyes. Believe me, drugs don't have eyes. Drugs recognize the structure. Drugs only have that specific kind of receptors that will recognize the structure of the carbonic anhydrase, and this drug would bind at this point and inhibit this. Of course, this acetazolamide is going to inhibit this as well. But I didn't, mention this because if this carbonic anhydrase is inhibited, it is understood that this cycle is interrupted. My main intention was to tell you that this cycle is interrupted. That's why I didn't mention that this carbonic anhydrase would be inhibited as well. So, but as this student has asked, so let me tell you that yes, of course, this drug can pass through the proximal communicative tubular cell, and this would specifically bind at this point. And yes, both of these would be inhibited. Yes, any other question?
Sir, one more question. Sir,
Okay.
how effective this acetazolamide as compared to other diuretics?
Okay, again a very intelligent question. Okay, let me tell you. Actually, when I was talking about the sodium reabsorption at this point of the proximal communicative tubule, I must tell you there are some other diuretics. So actually he knows something more. That's why he's very curious. So anyway, let's come back to the question. Actually, when sodium is being filtered at this point, at the proximal communicative tubule, that is the initial part of the nephron, approximately 65 to 70% of the sodium is reabsorbed at this point. At this point, 65 to 70% of the sodium is reabsorbed. There are other parts of the nephron which also deal with the sodium. That thing I would be discussing in my later part of the lecture, in other lectures. But here I must tell you that this is the ascending loop of Henle, thick part of ascending loop of Henle. This also deals with sodium. Here 25% of the sodium is reabsorbed. Again, here also we have, okay, let me calculate, 65 and 90% is here, then 8 to 9% is reabsorbed here, and approximately here also we have 1 to 2% of sodium reabsorption. So if you look here, if you have a look, then just you can recall that this is 65 to 70% of the sodium is reabsorbed at this point of the proximal communicative tubular cell. Actually, this 8 to 9% of the sodium is reabsorbed at this point, and 1 to 2% of the sodium is reabsorbed at this point. But as per he was talking of the efficacy or the efficiency of this acetazolamide drug. See, acetazolamide is, of course, you might think that it is reabsorbing about, because at this part of the nephron, approximately 60 to 75% of the sodium is reabsorbed. You might be thinking that this drug is going to be very effective, but it is not the case. I must tell you that this is not the case, because if you give a drug which acts at this point, that is acetazolamide, of course acetazolamide, then there are compensatory mechanisms which come into play. And this part of the nephron would actually, if it was absorbing 25% of the sodium, it has a reserve capacity, it has a reverse capacity to absorb more sodium. Its efficiency, for example, if it was absorbing approximately 25% of the sodium, it would go up to 45%. This is the reserve capacity that was present in this part. This part also, the percentage of sodium reabsorption would increase, and this part also sodium reabsorption. So as a diuretic, I would tell you in the later part of the lecture that the diuretics which act at this point and this point are more better class of drugs to be used as diuretics. So as far as acetazolamide is a drug, the acetazolamide is considered as a diuretic. It is a better class of drug, but not better, not considered to be a golden standard drug. I told you the reason, because if sodium reabsorption is hindered at this point only, then the compensatory mechanisms in the distal part of the nephron won't allow much of the sodium to be lost in the urine and to be effective as a diuretic agent. So that's all about this diuretic. I will discuss next topic about the second class of the diuretics after a short break. So